Okay, as we go on to the back side of the paper, when you multiply complex numbers, please take it slow. It does seem pretty easy at the beginning, just make sure that you're following every step. So we multiply the whole numbers together just like we normally would. So we would have 7 times 5, which is a positive 35. When you multiply the i's together, you get an I squared. I squared is the same exact thing, remember from the front side, that I squared equals a negative 1. So your answer at the moment is going to be 35 times a negative 1, which we know is a negative 35. So letter A's final answer is actually a negative 35. If we look at letter B, I want you to simplify this radical negative 9 before we begin. Okay, if you are using from the example from the front side, you know that 9 is a perfect square, so you can take out a 3. A negative 9 underneath means a 3 times I. Everything in the parentheses we can leave as is. We'll get rid of those parentheses right now. So if you are distributing, you would get 9i minus 3i squared. Okay, remember, I squared is the same thing as a negative 1, so you actually have 9i minus 3 times negative 1. Multiply those together and you get 9i plus 3. This is not your final answer because it's not in standard form. Standard form has the 3 in front and then the imaginary numbers. So on Math Excel tonight, it'll ask you for it in standard form, so you want 3 plus 9i. Now with your next example in letter C, letter C has the distributive property, or you can use the FOIL method. I'm going to show you with the distributive property just so we can make sure that we all are following the right steps. So I'm going to distribute 4 to the negative 5 and the letter I. Okay, you can rewrite that as 4 times negative 5 plus I. Then I'm going to do the exact same thing with the negative 2I times the negative 5 plus I. If you are using the distributive property correctly, you would distribute these out and get a negative 20 plus 4i. Distribute again, get a positive 10i minus 2i squared. So we can combine like terms again, as well as we can get rid of this I squared over here. So let's get rid of that I squared first. A negative 2 times I squared is the same thing as a plus 2. Remember, a negative times a negative is a positive. Now we can combine like terms really easily. You'd have negative 18 plus 14i. Final answer. Okay. Letter D is probably the biggest trick of all because this little exponent 2 means that you're going to have two groups of the 6 plus 2i. So when you multiply those together, I'll use the FOIL method for this one. You multiply your first term times you multiply the first terms and then the outer terms. You get 36 plus 12i. Multiply your inner terms together. Get another plus 12i and then a plus 4i squared. Please be careful with the I squareds. Remember that I squareds are the same thing as having a negative. So if you want, you can just replace this with a negative 1. So that would be the same thing as a negative 4 on the end. So 36 plus 12i plus 12i minus 4. Your final answer is going to be 32 plus 24i. So curl your final answer. With letter E, remember, this little exponent means that you have two things timesing each other. You have negative 8i times a negative 8i. Negative 8 times negative 8 is a positive 64. I times I is a negative I. is an I squared. I squared is the same thing as if you had a negative 1. So your final answer after you multiply positive 64 times a negative 1 is a negative 64. Looking at letter F. Letter F is tricky. Inside your first parentheses, you have a negative times a negative radical, or radical 4 to the negative. If you wanted to rewrite that, that's the exact same thing as if you were to write a negative 2i times 3 minus 3i. Distribute just like you normally would. Get a negative 6i plus 6i squared. Remember that I squared is the same thing as if you were to have a negative 1. Make sure that you are writing your final answer in standard form for us. It would be a negative 6 times a negative 6i.